Herzlich willkommen bei Traktionssysteme Austria.
Welcome to Traktionssysteme Austria. We're here at the test field where all our machines have to pass a defined test program before shipping. The most demanding tests, however, are those for type approval, where motors with complete new designs are being tested in every aspect. This not only means testing electrical parameters, but also, Rudi?
But also proving thermal stability, the amount of cooling air, and the emitted sound levels, and some more mechanical tests. But to get to that point, it is a long way, which starts with the design of the whole machine at our engineering department.
At these desks, our engineers develop new motors, generators, and gearboxes for rail vehicles. Development takes place in close collaboration of our experts in different technical fields, which is electromagnetic design, mechanical design, thermal design, but also fluidics. Stefan, what is crucial for the design of a traction motor?
We're facing ever-increasing demands. Motors are being run at higher temperatures, and customers expect a higher performance. Power efficiency and environmental neutrality are, more than ever, focal points for rail traffic operators. To meet these demands, we need traction motors with optimized efficiency.
What can be done to meet these extreme specifications?
One aspect is an optimized cooling duct positioning and optimized cooling duct geometry.
You're completing your dissertation at the moment, which deals precisely with these questions. What was your starting point for optimizing a motor?
I went into detail with the placement of the cooling ducts, starting with round holes and how to distribute them in respect to electromagnetic properties. The distance between holes and towards the edges of the rounds. Then I went on to more complex shapes, like these trapeze-shaped ducts. Again, the placement of the holes is of great importance to avoid bottlenecks in the magnetical field. In fact, it means finding the best combination of magnetical and thermal design.
Hi, Christian.
Hello.
Die thermischen Anforderungen werden immer größer.
Thermal properties are becoming more important. What can we do in the design phase to take that into account?
Diese Einflüsse zu berücksichtigen.
Here at TSA, we use a computer simulation for fluid mechanics, which calculates the complete airflow inside the machine, even where we could not place sensors. For example, this is an air model of a machine. Air model means what we see is air, no machine parts. This animation shows the variation in airspeed when a ventilator wing is passing by, and the effects in the cooling duct. We see a slice of one cooling duct.
We always have to find a compromise between airflow and the level of noise emissions. Can we calculate the noise level in advance?
We built up a good deal of experience to estimate the expected noise figures. Doing this by software is not really possible. This is way too complex. Also from the perspective of computing power. This is why we invested in a 3D printer. We can print different designs of ventilators and compare them in the test field.
The tests are finished now. To me, the motor sounded rather quiet. Does this reflect in the data?
Yes, Stefan. We've got the results on the monitor here, and it turned out that the noise level is lower than ever.
Okay, what does this mean in respect to the airflow and the thermal behavior of the machine?
With the optimized ventilator and your new cooling design, reduced airflow gives the same temperature and lower noise emissions.
I think our efforts have been successful. The optimized design was a great improvement.
I'm also very pleased with the results. But we're not finished yet. Research and development has to go on. And that is why we have some new projects under development, already started. And we're all very excited, waiting for the results.